All right, this problem's asking us to use the alternating series error test. What's the least number of terms necessary to approximate this series within plus or minus 0.001 of the actual value? All right, so if we want to be within that value, we want to test the next term, the n plus 1 term here in order to do that. And we want to do it with the absolute value. So for this series, we want to do the absolute value of this series to the n plus 1. So anywhere there's an n, add an n plus 1 to it. So on the bottom, that'd be the same thing here, n plus 1. And the absolute value of that should be less than or equal to then the absolute value of the plus or minus 0.00. Okay, so absolute value of what we have on the left there, we know any alternating term, this whole top part, if we take the absolute value, it's either going to be -1 or +1. It doesn't matter though because the absolute value of both is +1. So that's just going to end up being +1. On the bottom then we got n plus 1 to the third being less than or equal to absolute value of the right part would be 0.001. Okay, to solve that, let's multiply by our denominator here. So let's multiply by n plus 1 to the third. And at the same time here, we're not going to want that 0.001 on the same side. So let's divide by that. So we're going to divide by 0.001. And so what we're going to have now is that these should cancel. These should cancel. So now our statement here is that we're going to have 1 over 0.001 being less than or equal to n plus 1 to the third power. I'm just going to divide that. If you go on your calculator and divide 1 divided by 0.001, it should end up being that that is 1,000. So now we got n plus 1 to the third compared to 1,000, and that I'm going to switch sides on these, so I need to reverse my inequality sign so that the open side is still to the n plus 1 to the third power. All right, if we want to finish this now, our next step should be to cube root both sides. If you go on your calculator and cube root 1,000, that should be 10. And then last step, we want to minus 1 here. So n has to be greater than or equal to 9. So the least, on this one, the least number of terms then necessary to approximate within that value would be 9 terms. We need at least 9 terms to make sure our answer, our sum comes out to be within 0.001 of that. So if we wanted to set this up, we would do a partial sum from 1 to 9. And if we did that and added that up, the value of this should be within this amount of the infinite sum over here of that. All right, let's have you try one out here that's kind of similar here. So using the alternating series test, what's the least number of terms needed to approximate the series within 0.001 of the actual value? So why don't you pause and try this one out and see what you get. All right, for this one, we want to do absolute value here of the n plus 1. So you can see we added n plus 1 where the n's were. Should be less than what we're looking for. The left side is just going to simplify to 1 over n plus 1 squared. Right side we got 0.001. I did some cross multiplying here. If you divide 1 by 0.001, you get 1,000. Should be less than n plus 1 squared. If you do square root of 1,000 to solve, it's about 31.6, and finally minus 1. So the number of terms needs to be greater than or equal to 30.6. That's not a whole number, so it looks like in this case we would need to use 31 terms of this in order to get our error to be less than 0.001 away from the actual value. So if you came up with that, nice job. If not, that's what we should have been looking for on this one.